Maybe it's the cold weather, I don't know, or the snow. Who knows?
I've done it before. I understand.
All right, so find the derivative of the given function. You want to start with number 1?
Yeah, or number 2.
Okay. That's fine. Let's see here. Hold on a minute. And unfortunately, I'm going to have to apologize again. I do have a 5 and a 6 o'clock today. So if you still need help at the end of this session, if it's helpful to you, I can get back to you at 7.
Okay.
Okay.
Will 7:45 work? Because I do have a hair appointment.
It will. I have nothing else after 7 tonight. So I don't want to shortchange you on your time.
All right, that'll work. 7:45.
Yeah, let's talk about that when we're done, but yeah, that'll work.
Okay.
So let's look at number B.
Or actually, I think I want to do number 2, and so those are that's just a multiple choice problem.
Okay. Oh, I get it. Yeah, excuse me. I was not looking at it right. All right.
No worries.
So y equals inverse tan of square root of 3x.
Yes.
All right.
So my work is at the bottom. I think my main issue is, I just don't know what I'm not getting.
All right, let's start
I don't know
simpler.
how to reach.
If y was equal to inverse tan of x, then y prime would be 1 over 1 plus x squared.
Yes.
Okay, so what we're going to do here is instead of x, it's square root of 3x.
Oh, plus x.
So y prime is going to be 1 over 1 plus, now in here I put square root of 3x squared.
Oh, okay.
And then I have to multiply it by the derivative of the inside. In other words, what is the square root of 3x derivative? Square root of 3. In other words, you have to apply the chain rule here.
Okay.
Okay. Now,
I think I wrote down, yeah.
The chain rule, the trick with the chain rule is always to identify the inside. Okay?
Okay, right.
Now, let's see. I don't see this answer on there. Why is that?
It says C should be the answer.
I see what happened here.
Probably because they simplified.
No, there's 2 insides.
They didn't simplify.
And there's 2 insides. In other words, the initial inside is u equals square root of 3x, which is u equal 3x to the 1/2. And the derivative of that, u prime, equals 1/2 3x to the minus 1/2 all times 3. So that's the derivative of the inside. It's actually a double application of the chain rule. And so in the numerator, in other words, that's the derivative of the outside, right there.
Okay.
But then when I multiply it by the derivative of the inside, I get, well, let's see. I get 3/2 times square root of 3x in the denominator. So that's u prime. And I'm multiplying it all by that. So I'm multiplying it by 1 over 1 plus square root of 3x squared. So let's see, what is that? That is 3 over, let's see, the square root of that squared is just 1 plus 3x. So let's see, I got this times 1 over 1 plus 3x. And an answer, it should be 2 square root of 3x times 2 square root of 3x times 3x. I think I did that correctly. And now the 3's cancel. No, they don't. Oh, a terrible time to fall asleep right before a calculus session. Let's see. That 3 times, it looks like 12. The 2 times the 2 times the 3. So if I simplify that whole thing, I get 12 times 3x times 3x, I believe. Well, hold on. If I multiply all the numbers, I get 2 times 2 times 3, which is 12 in the bottom, 3x times 3x times 3x. And then that will cancel with that, and I should have 1 over 36x squared.
Wow.
And you're saying C is the correct answer?
Yes.
Well,
maybe they just didn't simplify as far.
I was going to say, that looks maybe like the same answer. Let's see, 3 over 1 plus 3x times 2 times 3x in the bottom. That's what I have. Yeah, it is. In other words, if you look at this step here, I believe that's what I have. 3 over 1 plus 3x times the quantity, 2 times square root of 3x.
Yeah.
That's answer C. It's just that I went ahead and simplified. I don't know why they didn't simplify it. They really should, because you can, and you end up producing something that can be reduced. But yeah, C is the same answer as I get.
Alrighty. I think the issue with that one was I just messed up on the...
Well, it's a double chain rule application is what it is a double chain rule. Okay? It's not just the inverse tan of u, it's the inverse tan of u, and then u needs the chain rule applied to it also. So it ends up being a double application of the chain rule.
Yeah.
All right. let's have a look at 3 here. It's only a single application.
Actually, is there, can we move on to a different problem? 3 was pretty good.
Sure. Which one? Next
I
page?
sent you multiple images.
Yeah.
The second image should have it on.
I got them.
Alrighty, 14.
Okay. A function is decreasing when its first derivative is negative.
Right.
A function is increasing when its first derivative is positive. Okay? So let's see what the first derivative of this is. If f of x is 48x minus x cubed, then the first derivative is what?
Wait, repeat.
If that's the
it would
function,
be
what's the first derivative?
48 minus 3x to the second.
And so we want to know where that is less than 0. Okay, well,
Okay.
we'll set it up as an inequality and then solve it.
All right. So
That's less than 0, so I subtract, let's move the 3x on the other side. So I have 48 is less than 3x squared. Divide both sides by 3. 16 is less than x squared. And now what's the solution to that? It's a little tough with any
so 4.
Like, if you take the square root of both sides, you have to say, well, the positive solution is where it's greater than 4. But then when I look at the negative solution, minus 4, it has to be less than that. So I get x greater than positive 4 or x less than negative 4. Notice that with either of those cases, x squared is greater than 16. When x is either greater than 4 or less than minus 4. So where is that here? Oh, I didn't quite get the whole problem. It was where it was increasing, where it was decreasing. Well, it's pretty easy to see that it is increasing, it's decreasing whenever x is less than 4. It's going to be increasing when x is between minus 4 and 4. In other words, here you have to give this an interval notation. So here's what we have. It's decreasing on this interval, minus infinity to minus 4 in combination with 4 to infinity. And it's increasing everywhere else, which is minus 4 to 4. So
how did you know it was decreasing again?
It was
is that just because
the first derivative is less than 0.
Less than
In other words, yes, that's one of the key fundamentals of algebra, is that if a function is increasing, then its first derivative will be greater than 0. If a function is decreasing, its first derivative will be less than 0. So it's see. Yeah, it's increasing negative 4 to 4, and it's decreasing negative, like I said there. And you'll notice that it's parentheses around everything, because at negative 4, it's neither decreasing nor increasing. Same thing with 4. In other words, if I were to try to draw a picture of this function, here's minus 4 to 4. It might look something like this. It's decreasing on that interval, it's increasing on that interval, and it's decreasing on that interval.
Right. Gotcha.
And
all right, easy
this
enough.
is the original function. In other words, this is f of x equals 48x minus x cubed. If I were to graph the original function, it would look something like this.
All right.
I could almost graph the first derivative. I could. Is all I have to do is find a first derivative that's decreasing from there to there, increasing from there to there, which means the first derivative is positive, and then when the original function is decreasing, the first derivative is negative.
Alrighty.
All right. Let me grab a look at my schedule here. I feel horrible. Thank goodness I can give you a little bit of time. You said it's 7:45, right?
Yes.
Okay. Matthew, you must spell your name with 2 T's. Yeah. Matthew, I will call you back at 7:45.
All right. Sounds good.
Okay. Bye-bye.
Thanks.